The following is a demonstration of software written to aid in the visualization of dominant language constellations. This demonstration bases itself off of a dataset of 53 respondents, all of which present a variety in age, gender, and geographical origin, as well as a variety in languages spoken, which is of great importance to the subject at hand. The first ability of our tool is the ability to visualize an individual respondent. We do this by using their identifier in the dataset and by loading up the visualization of their dominant language constellation. There are two shapes here, a cube representing the respondent and spheres representing the language that they speak. The size of the sphere represents the proficiency of the respondent in that language, and the distance of the sphere to the respondent is the familiarity that the respondent has with that language. The distance between the languages itself is the self-determined distance that the respondent considers these two languages to have based on their own experience. We also have a description aid for this visualization, which tells us what various colors represent in terms of languages. The second ability our software has is that it enables us to visualize the global dataset of respondents in terms of the languages they speak and the average distance between these languages as reported by the respondents. Here on the side, we have a listing of the languages represented and the number of speakers of each individual language, as well as then the average distance between each single language represented. For example, English, which has 46 speakers within our data set, and French, which has 24 speakers in our data set, are considered to only be distant by 5.74 points out of 10. However, Russian, which is spoken by 4 of our respondents, is considered to be at an average distance of 8 with English. Another ability we have is the ability to filter out certain elements based off of languages to constrain the data set. For example, if I were to take the Arabic language and Japanese and load the subset, this subset is quite relatively smaller than the previous one we saw. This helps us constrain our field of study. Our most important tool remains the comparison tool, which enables for any specified respondent to load up their representation. So this is the representation we saw earlier when we were viewing an individual representation. So someone that speaks Spanish, French, Japanese, and English, with the closest available representation, so someone that speaks English, French, Dutch, German, and Japanese, with the most dissimilar representation, someone that speaks Russian and Nauruan, with another random baseline representation, which is someone that speaks only English. This enables us to really select comparisons and be able to determine whether or not the individual we are looking at is quite divergent from the dataset or quite common, and also how they relate to other individuals in the dataset.